Isn't this great? We've finally reached the point where we're going to begin configuring our first Cisco device, a Cisco switch, as we walk through the initial setup of a Cisco switch. What I'd like to do is talk about how you will take this piece of equipment out of the box. Well, maybe not that basic, but look at it, understand what's going on by looking at the physical indicators, watch the boot process when you first plug it in and watch it boot up so we can walk through what exact output happens when the switch does boot up. Then we'll get into the iOS and perform an initial configuration to where you can set this device up and manage it remotely. When you first order this Cisco switch, you're going to have about well, anywhere from a 2-day to a 2-month lag time, depending on what vendor you go through and how you get this switch shipped to you. But you'll eventually get that box in the mail. It's got the Cisco logo on it. Put it where you want it and open it up. Now, the first warning I will give you is that you will only get the new switch smell one time. And that is when you first open that box and peel back the plastic that's surrounding that switch. It blows away the new car smell. There's no comparison. Just take a deep breath. It's kind of a mix between plastic, cellophane, and just new switchness all about it. Take that switch, mount it where you want it, and power it on. Now, as you power it on, you're going to see over on the left-hand side of most of the switches, you're going to have this array of lights and probably a mode button of some sort. Now, that mode button may look different depending on the device that you're working on, but there will be some sort of button on all their stackable switches. And what I mean by that is just these real thin 24, 48 port switches that you can buy and just stack and put anywhere. Now, those lights are pretty essential. First thing that you'll see over here is a system and RPS light. You can see that's these guys right here. The system light is the system status. As it powers on, that will typically be blinking green. Just think when you see these lights, green is good. Amber, kind of a yellow color, is bad. You never want to see amber. So the system light will be blinking green as it's booting up, and eventually will go a solid green once it's booted. Now, if that light changes amber, stop right there, ship it back, because there's something wrong with your switch, and you'll get another chance at that new switch smell. RPS, that stands for redundant power supply. A lot of the switches have the ability to have two power supplies installed inside of them, so you can have two separate battery backups or two separate power jacks. So if one of the power supplies or plugs go bad, you have a backup. If you have a redundant power supply and it's plugged in, that will be lit green. That's the second one right below it. Now below that, you have a row of 4 different selectors: stat, util, duplex, and speed. That's where this button comes in handy. By pushing that mode button where the arrow is pointing, you're actually going to flip between each one of those. It's different modes. Stat is the default, and that just shows the status of the port. If it's detecting a signal, like something is plugged into that port, it'll be green. And some of the switches will actually allow it to blink when it's getting some network activity, like it's sending or receiving some data. If it's nothing's plugged in or there is no signal, the stat will be dark. There will be no light on it. Now, if you hit the button and you go down here to util, that is actually short for utilization. I don't know if you've ever seen those stereo equalizers where it kind of shows the bass and the treble and all that kind of going up and down, and you can watch as songs play what it looks like. But the util kind of turns your switch into a type of equalizer. All of the lights go into this utilization mode that will show you the current utilization on the switch. If you had maybe 10% utilization, then this light, this light, this light, and this might be lit up. If you're up to 100%, then it'll be lit up all the way across all those lights. I'm only showing you a quarter of the switch right there. And if there's no activity, it might just have one light or no lights lit at all. It just is a constant monitor of how much throughput, how much traffic is currently going through the switch. The duplex, if you hit that mode button one more time, the duplex light will light up, and it will show a light, the ports will light up that are configured in full duplex and are currently working in full duplex mode. The ones that are not lit up are considered half duplex, so that will tell you those are in half duplex mode. The last one is speed. Hit the button one more time, it drops down to speed. That will tell you if you are in 10 meg or 100 megabit per second mode. The light will be on for 100 meg, will not be on for 10 meg. Now that we know what the switch can tell us just by looking at it, let's get into the initial switch configuration. Now I have a connection to the switch console port, and you can see right now nothing is happening. I have to boot the switch up. One of my things I want to walk through with you is the boot process of the switch. The only catch is the switch is in the other room. Now normally I'd pause the video and then go plug it in and come back, but I want you to see it in real time as the boot process happens. So let me just put down my headset. I'm going to walk over to the other room and plug in the switch. All right, the switch is plugged in. We've got some data. It looks like some strange character that came across the screen, probably just some uh, gibberish as the switch begins powering up. There is no power button on a switch, so you literally have to plug and unplug them to get them to boot. Now, normally it happens quite a bit faster than this. So there we go. It just came up and said, my base Ethernet MAC address is such and such. That's the MAC address that the switch uses to communicate. Talks a little bit about the flash file system. That's where it's storing its iOS. And right now what it's doing, you can see all these pound symbols flying across the screen, is it's taking the iOS from Flash. You can see this right here. That's the actual file name as it scrolls off the screen in Flash, and it's copying it to RAM and uncompressing it. That's so that it will run at a fairly decent speed. You see some copyright information. You can see what model of switch it is right there. This is the switch model. This is the version of the iOS that I'm running on that switch. And right now what it's going through is kind of like a power on self test. It's going through each component inside of that switch, just testing it to make sure everything's operational. The processor, the memory, the interfaces one by one. Now if you were looking at the switch, you would see the lights ticking down, going tick, 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 one at a time as they work their way down. Now this is a little more about it. Right here is where it shows its memory. You can see it kind of wraps around. 65,526K slash 8192K bytes of memory. Now Cisco switches, and I should say Cisco devices in general, switches and routers will partition their memory. It actually breaks it into two separate chunks. So if you're ever wondering, well, how much memory does this device really have? You have to add those two numbers together. Now down here it says what kind of switching image it's running, shows the interfaces that are installed. The main summary that you can see is right here. This switch has 24 fast Ethernet interfaces and 2 gigabit Ethernet interfaces plugged into it. It shows how much NVRAM it has, non-volatile memory. That's where it stores its configuration. Oh, I clicked up. Some part numbers and so on. Now, one of the things that you're going to have to get used to on Cisco devices is you're always going to get output. Like all of this junk right here is just output, status messages, updates. Hey, here's what's going on. Now you notice right before that, it stopped to ask you a question saying, would you like to enter the initial config dialog? Honestly, it's still asking that question. Right now, it's sitting there waiting for the answer. I've seen a lot of people, myself, I've sat here and I've stared at this like, okay, where's my prompt? It's not going to come. It's waiting for you to do something and answer that question. It just had a bunch of status messages that came up in between. So one of the things you'll need to get used to is just hitting the enter key. Hitting the enter key will typically allow it to reprint what it was last printing if it's a question. And we'll see more of that later. The tab key is also very helpful for that. So it's saying, please answer yes or no. Would you like to enter the initial configuration dialog? Now I will tell you, in the real world, which most of you will be in, where you are in live networks configuring devices, 99% of the time you will answer no. I'll even add a 0.9 to that. 99.99% of the time, you'll answer no to this. This is actually I guess you could call it a setup wizard. It walks you through the basic setup of this Cisco switch to try and get it running. The problem is, I'll show you what it looks like. I'll hit yes. It says right here, at any point you may enter question mark for help, control C to abort. Default settings are in square brackets. That's what it's talking about between here. It's a wizard that kind of walks you through the basic setup of a switch. The reason nobody uses this in the real world is once you know how to do it from the iOS, from the real command line, you'll prefer to do it that way. As in, you don't want to be prompted. You'll just go in there and set it up. I guess, I don't know, if you've ever met somebody who is a Linux person, I dream of being a Linux person. I want to learn Linux. I've never had the time to really sit down, and I just don't even know where to start. But the dream Linux people will put in the CD, and it comes up with the Linux setup wizard, and they'll be like, no, I don't need this. And they'll exit out of the wizard. I'm like, what are you doing? It's walking you through the setup. They're like, oh, I'd rather do it manually. I have more control over what's going on. And it's the same way in the Cisco world. Once you get these, the knack down for setting it up, you're just gonna be like, hey, that's the way I want to go. I don't need any wizards for it. So it's gonna first ask you, do you want to enter basic management setup? Right above it gives you a description. It says basic management gives you enough configuration so that you configure this remotely. Here's the idea. These switches are typically in very inconvenient locations, like mounted in a rack in some very, very cold IT room, or in some wiring closet that's very, very hot and very, very cramped. And you don't want to stand there very long. So what this does is give it just enough configuration so that you can telnet to it remotely. So if you say yes on basic management setup, it's just going to say, well, give me an IP address. Tell me what my default gateway is, that kind of thing. But I'll say no, just so you can see the real wizard. It says, would you like to see the interface summary? Yes is in brackets. Anytime you see something in brackets, enter will take that default. I'll hit enter. Comes up and says, here is your list of interfaces. Currently, everything is down. You see all of my fast Ethernet, 0/1 through 0/24. Remember I said it had 24 interfaces, and 2 gigabit Ethernet interfaces. Those are down as well. Now it's going to come up and say first, what do you want to name your switch? I'll go ahead and say this is Jeremy switch. You can do that when you own the switch. What is your enable secret? That'll be the password that you want to use to protect the privilege mode. If you remember back from when we were talking about the iOS, I talked about user mode and privilege mode, and you type in enable to get there. Well, the enable secret is the password to protect that. So I'll just type in Cisco. The worst possible password you could ever use on a Cisco router. Now it comes up and asks about the enable password. I know you're thinking, wait a sec, didn't we just answer that? I'll talk about that in just a moment when we get into the manual configuration. I'm just walking through the wizard right now. It does also protect the privilege mode. Now it's asking for the virtual terminal password. This is, in essence, the telnet password. If somebody wants to telnet to the device, even to get into user mode, what password do they have to give? We'll say telnet. Would you like to configure SNMP? No, no, no. Says, do you want to configure VLAN 1 interface? I'll hit no for now. Do you want to configure fast Ethernet 01? No, no. You getting the idea here? Not the most convenient. All right, I'm stopping. Not the most convenient way to configure your switch, because you're not going to go into every single interface and configure them individually. When you go into the command line, there's ways that you can configure them all at once using it's a command called interface range. So that's why most people don't like using that wizard, and once you see it, you'll always answer no. So let me scroll back up and just emphasize, if you're on any device, doesn't matter a switch or a router, and you get asked the question, would you like to enter, where'd my window go? There we go. Would you like to enter initial configuration dialog? Answer no. If you do accidentally answer yes and you get stuck in this land of great abyss of config, just hit Control C. That's what I did right there, and it will exit you out of there. Press return to get started is what you want to see. Again, you're going to get these messages all the time. Don't worry. It's just status messages. Something happened. The switch wants you to know about it. Just hit enter a couple times, and there I am sitting at my user mode prompt. So from here, this is where we want to be to perform our initial switch config. Now you may remember from the previous video when we talked about the iOS fundamentals, the different modes of the iOS. As of right now, we are in user mode. From here, you cannot do anything. You just can do some very basic show commands. So we want to get to privilege mode. The way to do that is to type in enable. As of yet, this is a brand new switch, so there is no configuration on it. Now from privilege mode, I have full access to the switch. I can do anything I want, but remember from this mode right here, to review from the previous video, you can't really do any config. You can just show anything. I can see anything that's set up on the switch from privilege mode. So to do the initial configuration, I want to get into global configuration mode. I do that by typing in configure terminal, or conf t if you want to use a shortcut. I just hit the tab key as I was typing to finish the commands. Now, once I'm into global configuration mode, the first thing I'll want to do, and this is initial switch config, on a brand new device is set the name. The way to do that is type in host name and what you want the name to be. I'll just say CBT switch. And I hit enter. As soon as I do that, you see that the prompt changes to CBT switch. Now there's a lot of different arguments for what you should name your Cisco devices. Some people say you should name it logically, which means you will say this is, for instance, I could say host name, third floor, wiring closet, switch 1. Or something like that. So immediately when I telnet into this device, I just look at my little code that I have there and I go, oh, this is the third floor wiring closet switch 1. You also have the people that argue, well, I like to name them with a theme. I found the most popular theme to be The Matrix, because everybody that's in Cisco loves The Matrix, the movie. So you'll see switches called Neo and Trinity and Morpheus and things like that. I prefer my advice is to use this kind of standard. Seriously, I have had long conversations with people that get quite aggressive because they're like, no, I like naming it with names like this, or Sesame Street characters or whatever, because in the argument that I've heard is if somebody hacks into the switch, they won't know where they are in my network if I haven't named it logically. Like if they hack into this switch, they'll know exactly where they are in the network. And I to that respond, granted, you are correct, but the problem is not that they know where they are. It's that they hacked into your switch in the first place. That shouldn't happen. So that's the problem. So anyway, I'm debating with myself. You see my schizophrenic personality. So I'll just go ahead and change it back to CBT switch for now. That's the first thing, the host name. The second thing that you'll want to do is give the switch an IP address. We want to make sure that we can manage it remotely. Now, unfortunately, in order to give this switch an IP address, you have to have a basic understanding of this concept known as VLANs. You may have heard the term described before, VLANs. It's a very popular industry term. What a VLAN is, it stands for Virtual LAN, or VLAN. It's a way to take your switch and break it up into multiple broadcast domains. Okay, I'm racking your memory banks. Think back to when we were talking about the foundations of switching. I said there was collision domains, which said how many people could send at a time. And then you have broadcast domains, which says how far a broadcast will go. By default, if you have a switch, and this, by the way, is Cisco's mother of all switches. It's a 65, that one is a 6509 because it has 9 individual blades, but it's a 6500 series of switch. But there's just a ton of switch ports that you could deck this thing out with. 24 there, or 48 ports there, 24 or 48 there, 24 or 48. But by default, they're all plugged into the same backplane. They all connect to the same backboard back here, and they all are just one switch. So if one PC that's plugged into that switch sends a broadcast, it comes out every single one of these ports. That's where this concept of VLANs come in. Now, before I describe VLANs to you, I want you to know that VLANs are not part of this series. Meaning VLANs are further described and more fully covered in part 2, which prepares you for the CCNA. This is preparing you for the CCENT. I'm going to tell you what a VLAN is, but I just want you to keep in the back of your mind there is more than just what I'm telling you right now. This is just a broad overview. But I can take my switch. Let's just take this switchblade. If I were to pull that out and draw it up right here, We've got all these ports on that switch, and I'll just draw them in a nice straight line. Whole bunch of ports, every single one of those representing, of course, more than one. I could take it, if I wanted to, and split it into two VLANs. I could say, well, I want this to be VLAN 1, and I want this to be VLAN 2. And just like that, I magically change my switch into multiple broadcast domains. Meaning when a computer that's plugged into the ports assigned to VLAN 1 send a broadcast, it will only come out the ports that are in VLAN 1. It does not bleed over into VLAN 2. Likewise, if someone in VLAN 2 sends a broadcast, it will only come out those respective ports. Now you can see I have a lot more switch ports inside of here, so I could say those are VLAN 2, those are VLAN 1. I could chop it up however I want. And I could have more than one VLAN. I could say, I've got my miscellaneous port I didn't get a chance to circle, so he gets his own VLAN, VLAN 3. So we've got VLAN 1, 2, and 3. Every single one of them is totally isolated from the other. If you could visualize this, it's as if I could take that switch over my knee, if I was one of those super karate people, and go, yeah, chop, and chop that switch into 3 individual switches, and all of them still worked. That's kind of what VLANs do. It's one of those technologies that seems to be just about everywhere in larger businesses. That's why it's not in this part of the series, is because this is preparing you for CCENT, the entry-level network technician. You typically work with smaller networks that have yet to really get to VLANs. So why am I talking about all this now, if it's not even in this course? Well, we're getting to the point where we are going to assign the switch an IP address. In order to do that, we need to go into what's called a VLAN interface. See, even though we don't know we're doing VLANs, or really know what VLANs are in most cases, your switch is doing them when you pull it out of the box, whether you like it or not. Every single switch port on that switch is assigned to VLAN 1. That's why everything works without any problems. It's not like if you plug into one port versus another, one can reach the other or one can't reach another. Everybody can reach everybody because everybody's a member of VLAN 1. Now, on these switches, you have the ability to create something known as virtual interfaces. I usually draw them like that. I don't know why. I can create something known as interface VLAN 1. Now, I want to make sure I take a moment and distinguish. VLAN 1 and interface VLAN 1 are two very different things. VLAN 1 is the VLAN itself. I can kind of think of it like the fabric. It's the fabric that all these ports are connected to and that everybody can communicate on. They can do that whether or not I have interface VLAN 1 even created at all. If there is one or they're not, they don't care. They're all talking on VLAN 1 and happy as larks. Interface VLAN 1 is known as a virtual interface. It's a make-believe interface, but it responds. It's an interface that I can create on my switch that every port in VLAN 1 can access. So for example, if I said, well, I want to create interface VLAN 1, it's this little hook right here, and give it the IP address 172.1.1.1, I can do that, and automatically every single port on that switch that's a part of VLAN 1 will be able to reach this VLAN 1 interface. So if I have a computer here and it's plugged into that switch and maybe it has the IP address 172.1.1.2, then this PC can reach this IP address on the switch. Now, is that IP address assigned to an interface that I can see and touch? I mean, can I look at the switch and go, oh, there's the VLAN interface? Can I take it apart and look inside and see it? No, that's the whole idea of it being a virtual interface. It's kind of make-believe. It doesn't really exist, but in logic, I guess you could say, in the network fabric, if you will, it responds to pings. You can actually telnet to that IP address. And that is why I'm talking about all this concept right now. Is because without understanding what a VLAN is, just the basics, you won't really understand what this interface VLAN 1 is all about. So interface VLAN 1 is this virtual logical interface that its sole purpose that we know of right now is just to give an IP address to the switch so that I can telnet to the switch and manage it remotely instead of standing in the IT room connected to a console port. So Enough talk. Let's get back into the configuration. I can go in here and type in interface VLAN 1, and now I can give it an IP address. We'll say IP address 172.30. We'll give it 2.50. Nah, let's do 2.180. 50 is already in use in my network. So I'll give it that IP address and a subnet mask. Now, see, sometimes I've done that command so many times, I kind of get out of the habit because we're new at this. So we should be using the question mark. Remember, the question mark always walks you through these commands. So I type in IP address. That's all you have to remember. It says, well, go ahead and type in the IP address, 172.30.2.180. Question mark. What is the subnet mask? 255.255.255.0. Question mark. Now it's saying, do you want to make this a secondary IP address, or do you want to make it essentially the primary? It's assumed by hitting enter you're making it the primary. I'll do that. So I've typed in the IP address, hit enter. My switch now has an IP address. Now there's a catch. I'm going to exit out. Anyone remember how to completely get out to privilege mode? It's either Control Z or end. I'll type in end. So I exit out, get back to privilege mode, and type in show interface, and I'll look at VLAN 1, just so I can see what it looks like. And right here, I see VLAN 1 is administratively down, line protocol is down. Now, this first section right here, VLAN 1 is administratively down, represents the physical state of it. This, the line protocol is down, represents the data link state. It maps straight to the OSI layers. First one is the physical layer. The second one is the data link layer. Now, there's a problem because it says VLAN 1 is administratively down. Anytime you see administratively down in any Cisco switch configuration, that means the interface is shut down. Meaning by default, on most interfaces, you will have to turn them on before they work. The way that we do that is, well, it's shut down, so I negate it. No shutdown. Okay, the command to shut down an interface is shut down, so I can type in no shutdown to undo it. And by the way, as a side note, that goes for a lot of things. You can type in no in front of just about any command and it will negate it. For example, we gave this switch a name, right? I can type in no host name, enter, and poof, it goes back to the default name of switch. So you can undo just about anything that you're doing just by putting in a no in front of it. We'll see that plenty of times. All right, let me just put my name back on. You notice it says VLAN 1 has now changed the state to up. Our switch is now telnetable, meaning we have an IP address that we can telnet to. But we're not done. By far, we're not done. We need to give it a default gateway. This switch has to be able to get off its network. So you might have this switch that eventually connects to a router. Whoa, not that kind of router. That's a Juniper router, not a Cisco router. We've got a router that connects to the internet or connects to some other part of your network. Who knows what it's connected to? But that router is going to be its default gateway to get out. So maybe if my IP address was 172.111, maybe my router has 172.11, we'll say 10 is its IP address. That would be the default gateway that the switch uses to get out. Now on my network here at my recording studio, the default gateway is 172, let me just hit the question mark, 172.30.2.1, at least for the network that switch is on. So the command is IP default gateway, and notice what mode I'm in, global, IP default gateway 172.30.2.1. Just want to prove to you one more time. I'm going to type in IP diff and just hit question mark. Notice I can type in default gateway or default network. That's why when I hit the tab key, which I did right here, it didn't finish the command. It didn't know whether I was typing default gateway or default network. So when you hit tab, it's like, well, I'll take you up to the point before I need you to tell me what direction you're going. You either type in N, and that'll put in network, or G, and that'll put in gateway. So that's the command from global config mode. I want you to see this. I'm going to go under interface VLAN 1. Check this out. I'll type in IP default, and I'll hit the question mark. Unrecognized command. The mode that you're in as I said before, is more important or as important as the actual command you're typing. You have to be in the right mode, and the default gateway is configured globally because that affects the whole switch. It's no matter where you are on that switch, it only has one default gateway. Good. So I'm going to get out, and the last thing I'm going to show you on this initial configuration, no, a few last things, is is how to lose your connection to the switch. For some reason, I've lost my connection to the switch, but that's okay. I'll fix that in just a moment. I want to show you how to save your configuration. Huh, that was weird. I just lost my connection to my switch and had to bring it back up. I guess that's the disadvantage of having the equipment in a different room. So what was I talking about? Saving your config. Every single thing that we've been doing so far is saved in RAM right now. And I should put quotes around saved in RAM. It's considered our running configuration. Let me show you. I'll type in show running config. This is a big command that you'll want to keep in your mind. Show running config will show you what's currently running on your switch right now. It's literally every command that you've typed into your switch and some default commands that are in there. Like you can see, there's the hostname command, hostname cbt switch. If I hit space and scroll down, there's all my interfaces. Scroll down a little bit more. Yeah, there's interface VLAN 1 and the IP address I gave it. There's the default gateway. Every command that I put in will be sitting in that running configuration. The problem is that it is sitting in RAM. So if the switch loses power, you lose everything. So what we need to do is save our configuration to something more stable. That is known as the startup config. I'm going to type in the command copy running config space startup config. Enter. That will copy from RAM into NVRAM. Two guesses what NV stands for. Non-volatile. That's not going to lose itself if you lose power. RAM is considered volatile. It's unstable. If you lose power, it's gone. Now, be careful because I've seen a lot of people, when they get to this point, they see destination file name and it says startup config, and that's in brackets. That'll be what's by default. And they said, well yeah, yes, that's what I want. And they hit enter right there. If you do that, it will actually save your running config as a file named Y. You don't want to do that. I don't even know why they give you this option because the only file name that the switch looks for when it boots up is a file called startup config. So if you want to name it that, you don't have to do anything because that's the default. That's what's in brackets. So all we need to do is hit the enter key. It says building config, OK. The configuration is now saved. Now I can type in show startup config and hit enter, and I'll see the same exact thing that I saw reflected with the running config. It's just now it's hard-coded and it's saved. Now it's really beneficial to have these two configs, one in running config, one in startup, because there's been many times when I'm going through, setting stuff up, blah, 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 and I get, 50 commands down the line, and I'm like, oh no, I totally messed this thing up. The switch is hosed, All I need to do is reboot because it will go back to whatever is in the startup config, whatever I last booted with, as long as I don't save my config along the way. So it kind of gives you a backup copy of your configuration at all times. So that is how you save your configuration. All right, last thing I'll show you is the show version command. Show version is really handy if you want to see what's going on your switch, kind of in a general sense. If you're in Windows, if you've ever been in Microsoft Windows and you right-click on My Computer, matter of fact, I'll show it to you in case you haven't seen it before. If I right-click on My Computer and go to Properties, you'll bring up, well, this is Vista. I'm not too fond of Vista. I like XP better. But it'll bring up kind of an overview. You see like Windows Vista Business, this is your experience, this is your processor, your memory, and all of that sort of stuff. Well, in the same sense, this is like the overview. Show version is the overview of your device. You see right there what kind of router it is, the 3550, the version of software that it's running, how long it's been running for. You can see the uptime. That's a big one a lot of times if you're wondering if the switch got rebooted. How much memory you have, hit the space bar and scroll down. You can see the exact model number of the switch. That's the manufacturer part number from Cisco. Let's see what else useful stuff. is underneath here. We'll look on routers. When we get to routers, there's actually a little bit more there, especially this configuration register. That's a big deal on routers. But for now, that's kind of an overview of the switch, is the show version command. So what we've hit, let me just kind of sum up right here, is some big topics. We've hit the setting the IP address on the switch, which allows you to telnet to it remotely, setting the default gateway, setting the name, getting in, saving your configuration, which we're going to be doing again and again and again as we go through these configurations. So our switch is at least logically ready for remote configuration. The only problem is it's not secure yet. That will be what we do in the next video, is going to walk through setting up the router security. So I hope this has been informative for you, and I'd like to thank you for viewing.